Okay, so for our last video, we're going to look at this stack here. A blue with a deep red on top of it.
But, so if you remove a deep red, and do the reds get replaced on it?
Yeah, that would be the rule. So if red can remove the deep red. So what do you think the value of this is in terms of being positive, negative, or zero?
Well, it looks like it's going to be negative because like there's this whole entire stack of reds on top and then this tiny just one blue.
Well, how do we figure out if it's positive or negative?
I think it's...
Let your brother talk.
So maybe we could like add another one.
Well, what's the rules for how we figure out whether something is positive or negative?
So the blues are +1, the reds are -1.
That's true. What happens when something's positive?
There are more low in blues than...
What happens in the game?
Blue always wins.
Okay, when the position is
Positive.
positive, blue wins. When the position is
Negative, red wins.
okay, when it's zero.
The person who goes first loses.
Okay. So if this is on the board, then this is the only thing on the board, so that's the position.
Yep.
So who's going to win this game?
Well, let's see what happens if blue goes first.
Okay.
So if blue goes first, blue removes this, red loses.
Okay.
So if red goes, red removes all these. The deep red gets like maybe six.
Okay.
And then blue removes this.
Wait. Careful.
These are on top of it.
They're on top of it.
Oh, so then blue removes that.
Uh-huh.
Red loses.
There you go.
Wait, but then this must be positive.
It must be positive. Yeah, so it can be very difficult to try to actually calculate the value of something.
Yeah.
But the way you can tell if it's positive, negative, or zero is by looking at the game and what happens in the game, who wins, who loses. So with this, all by itself is the only thing on the board.
Blue wins.
Blue wins.
So,
So that means what?
That means that this is positive.
This is positive.
but we said this was like negative infinity, but we add 1 to it and it's positive.
Well,
You're not really adding one.
you're putting one on the bottom and you're stacking them.
Yeah.
So something else is happening. It's a weird situation that's
Yeah.
happening. You're stacking them. But this is positive.
Yeah.
Okay. So why don't we try to have it compete against something that's negative
Well,
and see what happens here.
Well, I think let's just run this a few times.
Okay.
The blue going first. Blue removes this. Red removes this. Blue loses.
Okay.
Then red going first.
Red.
Red I would think remove this and put a bunch of reds on it.
Okay.
Then
Blue removes all that. Red removes this and blue loses.
So this is negative.
Okay. Good. So
So this is
the blue deep red versus a red loses.
This is positive and this is positive but less than 1.
It's positive but less than 1. So let's try 2 of them versus a red.
Well,
Okay. Let's see what happens.
blue goes first. Blue removes this. Red removes a bunch of these. And does that. Blue removes this. Blue loses.
Okay.
So that would mean
We have to check the other situation.
Which is what?
red goes first.
Okay. Red goes first.
So
Okay.
red-
Can you do this? Can you do this
See,
one, please?
red would remove one of these.
Okay.
And then I would think blue would remove this.
Okay.
Blue removes this. Red removes this. Gets back. Blue removes this. Red removes that, and then blue loses.
Blue loses.
So it's less than a half.
It's less than a half. Okay. Oh, no, blue, yellow. Okay.
Let's see.
Oh, sorry. Blue, yellow.
What happens here?
Okay, so let's, instead of actually going through all of the actions, let's see if we can just talk through the actions. Can you describe what happens in this situation if blue goes first?
So blue removes one of these stacks.
Okay.
So then and then red removes like it removes the deep red on top and then blue removes that. Then red removes the other deep red, and then blue removes that. Red removes the lone red, blue loses.
Okay, and what happens if red goes first?
And then red goes first. Well, sort of the same thing happens. Red removes this and gets a bunch of reds. Blue takes that away. Then it repeats for these three, and then there's just that red left.
Okay.
So I think whatever this is, it's a number infinitely close to 0, but not 0.
Why?
Because for any number of these stacks, you can keep doing it. You can just keep going through this action.
If you're red.
Yeah, any number of times.
Okay, so 1, 2, 3, 4, 5, 6. 6 of them against a single red loses.
Yeah.
10 of them against a single red, what happens?
Loses.
100 of them against a single red loses. Right?
Yeah.
Yeah.
So it's less than 1/100th. What else is it less than?
1
Billionth.
10 trillionth.
Yeah.
1 gram's number.
1 gram's number. Yes. So no matter how many of these, it's definitely positive though, because blue wins. When there's just one of them, blue wins. But no matter how many of them together, no matter how big you make the blue deep red army, it still can't defeat a single red. That's pretty strange.
Yeah.
That's pretty strange. But let's find a different way to show that it's positive. What happens in a blue red situation?
In just this.
Yeah, just those two.
Well, this is 0.
Okay, this is 0, so whoever goes
First.
first
Loses.
loses. So what if I just tilt it in blue's favor just a little bit? Like, we don't even know. This is
Infinitesimal amount.
infinitesimal amount. Who wins this game?
Well, blue should win.
Because it's positive.
So blue does that, red does that, blue wins.
Pretty weird, huh?
Yeah.
So what is this number?
So
That's infinitely close to 0,
But not 0.
but not 0.
It's a 1. It's 1 over infinities. It's 1 over infinity.
It seems to be.
Arg.
Pretty cool, huh?
Yeah.
Huh. So these are the surreal numbers. And they're different than the normal numbers that you encounter.
Yeah. I wonder what a deep purple is.
Well, maybe next weekend we'll talk deep purple. Okay?
Okay.
All right. Good work, guys.